Hi guys, today we will study interlock. So, what is an interlock? An interlock is designed to prevent something unwanted from happening. For example, I have a factory I/O scene open here. We can turn on or off the conveyor using the start and stop push button. And I want to create a logic such that if the safety door opens the conveyor should turn off, and when is closed again the conveyor turns on. Now the question is how to create such logic. Let's first think about how we can turn on the conveyor. For this, we can make use of the start-stop rung. Now the question is how to unlatch the logic when the door is open and then relatch it as soon as the door is closed. For this, we can add a normally open contact of the safety door sensor in series with the conveyor and the main latch output, as I have created here. This is a very simple example of how we can prevent someone from getting close to the working machine. Let's simulate it and see the logic in monitoring mode. When I press the start push button, the start light contact closes and the conveyor starts moving as the door was closed initially. When the door gets open, the conveyor stops and starts moving again when the door is closed. We can stop the simulation and open the door to see what happens if the door was open initially. We can see that the start light contact again closes but the conveyor is not moving, and when the door is closed it starts moving again. Now, I have a question for you. Have you seen this logic before? I did introduce it in a previous video, do you remember? If you can find where I used it, then comment here and I will tell you the correct answer. Now let's take another test case of interlock. In the same scene, I have another conveyor and a control panel to control it. Here I have created a logic to reverse the direction of the conveyor using an interlock. Just like the previous logic, we can create a start-stop rung to turn on the conveyor. However, this time we will also make a logic to decide which direction we want the conveyor to go. The direction can be controlled using the forward and reverse switches. As we did in the previous example, we can take the contact of the start-stop rung and create a separate rung for the forward and backward direction logic. Now if we connect the contact of forwarding and backward switches in their rungs and connect the conveyor coil, we can turn on the conveyor and move it in the forwarding direction or backward direction. But there is a problem: if someone pushes both switches at any instance of time it will damage the motor. So we will add the NC contact of the conveyor backward in the forward rung and the NC contact of the conveyor forward in the backward rung. This will make sure that only one instruction is true at a time and we can avoid equipment damage. Note, in both cases, we have created a logical interlock. Let's simulate it to see if it's working or not. When I press the start push button, the start light turns on. Now, if I press the forward switch, the conveyor moves in one direction, and when I press the backward switch while the conveyor is running, nothing happens as we have used an interlock. So we first need to stop the conveyor, and then if I press the backward switch the conveyor moves in the other direction. I hope now you know what is a logical interlock and how we can use it. Consider subscribing to the channel and hit the bell icon to never miss an update. The link to the factory I/O scene and WinSBS program is given in the description. Thanks for watching and I will see you next time.